Hello everyone. Today we will discuss some important terms related to waves. You know that the equation of wave is y is equal to a sine kx minus omega t plus phi, and this is the equation for a wave traveling along positive x direction. And we know that the wave along negative x direction is given by a positive sign between kx and omega t. Now we have some important terms. Amplitude, that is maximum displacement from mean position. Mean position is equilibrium position. Then if we draw a graph for the displacement of wave with time, this is sinusoidal. We can see we are just drawing a simple sinusoidal graph. So at any instant, how much is the distance from initial position, that is x, and when the wave is traveling, the particles vibrate about the mean positions. Now here in this case, if we consider two positions which are symmetrical, suppose this is one oscillation of the particle, this is the maximum displacement at this time and this is the displacement at this time. We know that y1 is equal to if we draw a graph for the displacement of the wave and time t, we know that the equation is sinusoidal. This will be the shape of the graph. Now if we consider this point and this point, this shows mean position and the sense of movement of the particle is this way. So if we mark this point as O, this as A, suppose this point and corresponding this point as B, C, this point and this point as D, E, and this point as F. So we can understand the concept of phase also here. As we have discussed in chapter 14, phase gives the direction and position of a particle at any instant, right? So from here you can see that particle at O and particle at A, these are having the same position with respect to the mean position, and the sense of movement is also this way, because this is one complete cycle, so here it will repeat. So you can say that here O and A are in same phase. If this is the particle, this is the particle again, this is having same position with respect to mean, this is having same position with respect to mean, and the direction is this way. So you can say points B and C are having same phase. Similarly, D and E are having same phase, but point F and A, if you look at point F and A, F is the particle at F, A is having this sense for moving, and particle at A is having this sense, upward sense. So points F and A are in opposite phase. Moreover, the separation between the points having same phase is called as wavelength. Or the other definition is the distance travelled in one oscillation. Right? That means you can say that the separation between B and C will be one wavelength. Separation between D and E will be one wavelength. Separation between O and A will be one wavelength, and wavelength is represented by lambda. Right? Then we have wave velocity. Wave velocity is the velocity of wave. So velocity, we know that velocity is distance upon time. So time taken to complete one oscillation is time period. And distance travelled in one oscillation is wavelength. So you can write down this as lambda upon t. This can be written as, if I multiply and divide this by 2 pi. So what will we get? This is 2 pi upon 2 pi. So this will be given as 2 pi upon t multiplied by This is omega upon k, right? Then we have wave number, which is k. I have already mentioned here. This wave number is number of waves, wave number. This is given by 2 pi by lambda. Then we have time period, time taken to complete one oscillation. Then we have angular frequency, that is omega. And one more important relation between phase difference and path difference. So if we want to find the path difference between F and A, so what will be the separation? We know that the separation between this is and this is lambda. So separation between this and this will be lambda by 2. So an important relation between actually this is the distance travelled in one oscillation. So the path difference will be given in terms of lambda only. We know that in one oscillation how much is the angle formed? 2 pi. And how much is the distance travelled in one oscillation? That is lambda. So you can say that 2 pi is equivalent to lambda. That means in one oscillation 2 pi angle is formed and one wavelength distance is travelled. So this way we are just writing the relation directly, that phase difference is equal to k delta x. We don't have to derive it. So this is phase difference is equal to, what is this? 2 pi by lambda into path difference, right? So suppose this has a path over here and this has a path up to here. So this difference will give me the path difference. So that will be in terms of lambda only. So phase difference is equal to 2 pi by lambda path difference. So if I want to find out the path difference for pi phase difference, for example, if delta phi is equal to pi, find the path difference, right? So how will we find that? We know that from this equation. Phase difference is pi is equal to 2 pi upon lambda into path difference. So path difference will be right. So this will be very useful later on for the numericals. So that's all about the important terms. That's all for now. Have a nice day.